Dark energy and dark matter are two of the most mysterious concepts in all of modern science. Together, they make up about 95% of the universe. And yet, despite how often they are mentioned in documentaries, books, and videos, they are also two of the most misunderstood ideas in cosmology. Many sources speak about dark energy and dark matter as if they are already fully understood, as if scientists know exactly what they are, where they come from, and how they behave. But the truth is far more subtle. In reality, these two components represent some of the biggest unanswered questions in physics, and confusing what we measure with what we understand leads to serious misconceptions. Let's begin with dark matter. When astronomers observe galaxies, they notice something strange. Galaxies rotate much faster than they should. According to the laws of gravity, the visible matter, stars, gas, and dust, is not enough to hold galaxies together. If only normal matter existed, galaxies would tear themselves apart, but they don't. Something invisible is providing extra gravitational pull. This invisible influence is what we call dark matter. Dark matter does not emit light. It does not absorb light. It does not reflect light. We cannot see it directly with telescopes. We only know it exists because of its gravitational effects. It bends light through gravitational lensing. It shapes the large-scale structure of the universe. It acts like a hidden scaffolding that galaxies form around. And this is where the first major misunderstanding appears. Dark matter is often described as a mysterious substance floating through space like a cosmic fog. But this is misleading. Dark matter is not known to be a substance in the traditional sense. We do not know what it is made of. We do not know whether it is a particle, a field, or something even stranger. All we know is how it behaves gravitationally. Scientists have proposed many candidates: weakly interacting massive particles, axions, sterile neutrinos, and more, but so far none of these candidates have been directly detected. Decades of experiments have searched for dark matter particles, and none have conclusively found them. So when someone says dark matter is this, they are going beyond what science actually knows. The correct statement is simpler and more honest. Dark matter is a name we give to unexplained gravitational effects that cannot be accounted for by visible matter alone. Now let's turn to dark energy, an even deeper mystery. In the late 1990s, astronomers made a shocking discovery. They found that the expansion of the universe is accelerating. Instead of slowing down under gravity, the universe is expanding faster and faster over time. This was completely unexpected. To explain this acceleration, scientists introduced the concept of dark energy. Dark energy is not a force in the traditional sense. It does not pull or push objects like gravity or electromagnetism. Instead, it appears to be a property of space itself. As space expands, dark energy does not dilute. It stays constant or possibly even grows stronger. And here comes another common misunderstanding. Dark energy is often described as anti-gravity or a repulsive force pushing galaxies apart. While this description sounds intuitive, it is not entirely accurate. Dark energy does not push objects through space. Instead, it causes space itself to expand faster. Galaxies are not being pushed away. The distance between them is increasing because space is stretching. Even more importantly, we do not know what dark energy actually is. One possibility is that dark energy is simply the energy of empty space, known as vacuum energy. But when physicists try to calculate this value using quantum theory, the result is wildly different from what we observe, off by a factor of more than 100 billion. This is one of the worst theoretical mismatches in the history of science. Another possibility is that dark energy is not constant at all, but slowly changing over time. If this is true, then the future of the universe could be very different from current predictions. The universe might freeze, rip apart, collapse or do something entirely unexpected. This brings us to a crucial point. Dark matter and dark energy are not known unknowns. They are deeper than that. They are unknown unknowns. We observe their effects, but we do not understand their nature. They are placeholders, names for phenomena that reveal the limits of our current theories. Yet many explanations blur this distinction. They speak with confidence, using clear language, giving the impression that these mysteries are solved. They are not. Another common confusion is mixing dark matter and dark energy together as if they are related. In reality, they are very different. Dark matter behaves like matter. It clumps, it forms structures, and it strengthens gravity. Dark energy behaves like a property of space itself. It spreads evenly and drives expansion. They share only one thing, the word dark, which simply means unknown. Understanding this difference is essential. When people misunderstand dark matter and dark energy, they misunderstand the entire structure of the universe. Galaxies form the way they do because of dark matter. The universe evolves the way it does because of dark energy. Remove either one, and the cosmos we observe would not exist. What makes this even more fascinating is that we live at a very special moment in cosmic history. Right now, dark energy has just begun to dominate the universe. In the distant past, matter controlled cosmic evolution. In the distant future, dark energy may completely take over. We exist at the transition point, a brief window where both forces matter. This coincidence raises profound questions. Why now? Why do we live at the moment that dark energy becomes important? Is this chance, or does it hint at deeper laws of nature we do not yet understand? Science does not yet have answers. What it does have is humility. Modern cosmology openly admits its limits. It tells us what we know, what we suspect, and what we simply do not understand. Dark matter and dark energy sit at the boundary between knowledge and mystery. They remind us that even with powerful telescopes, advanced mathematics, and decades of research, the universe still holds secrets far beyond our reach. And that is not a weakness of science, it is its strength. Science advances by identifying what it does not know, not by pretending to have final answers. In the coming decades, new experiments may detect dark matter directly. New observations may reveal whether dark energy changes over time. Entire theories may be rewritten. Just as our understanding of the universe has changed before, it will change again. For now, the most honest statement we can make is this: most of the universe is made of things we cannot see and do not yet understand. And that mystery is what makes cosmology one of the most exciting fields in all of science. In the next video, we will revisit one of the most misunderstood ideas of all, the Big Bang itself, not as an explosion in space, but as the origin of space and time, and why this misunderstanding changes everything about how we think the universe began. Stay curious, and thank you for continuing this journey into the unknown.